Welcome back. Right now, I want you to go ahead and pause the video. Hopefully you have your notes from the previous slides. And go ahead and decide whether each of these scenarios below is a combination, a permutation, or should we just use the counting principle? Go ahead and pause this now. So for the first one, we've got a medical researcher. We need 6 people to test the effectiveness of an experimental drug. We've got 13 people who have volunteered for the test. In how many ways can the 6 people be selected? Well, in this case, order is not important. We are not looking at a number of possibilities. We are choosing 6 people from a group. That is a combination because order in which they go is not important. For B, we've got a brand of pen that's available in 3 different colors and 4 tips. How many different choices? You should have said counting principle. We are multiplying to get those number of choices for the pens. We are not choosing a number of pens from like 20 pens. That would be a combination. C is a little trickier. A corporation has 10 members on its board of directors. We want to choose a president, a vice president, a secretary, and a treasurer. In this case, order is important because we are not just choosing 4 random people. We are choosing 4 people and putting them in specific slots. So this would be a permutation. Remember, a combination is when we are selecting some items from a larger set, but the order of those items is not important. The order is not important. So let's try some. For a segment of a radio show, a DJ can play 4 songs. He has 8 to select from. In how many ways can the program for this segment be arranged? Every time we do this, we want to think about whether or not what we're choosing could be repeated. Do you think the DJ would want to play the same song more than once? I don't think so. He's got 4 slots in which to put his 4 songs. In the first slot, he has 8 to choose from. Now, one of those songs has been used. So for the second song, which is going to go right here, there are now only 7 to choose from because we've already used one. For the third song, there's only 6 to choose from. And for the fourth song, there's only 5 to choose from. So now you would just get your calculator and use what we learned about the counting principle, 8 times 7 times 6 times 5, which he has 1,680 ways in which he could select those 4 songs. Now, how many different ways can a director select 4 examples from a group of 20 actors to attend a workshop on performing in a musical? Remember to think about whether one person could attend twice. So we've got 20 actors, but we only have 4 spaces with which to send them to this workshop. For the first person, he has 20 different people to choose from. But he's not going to send the same person to the same conference more than once. He now wants 3 different people. So there are no longer 20 to choose from. Now there are only 19 to choose from. Then 18 for the third person. Then 17 to choose from here. And so we would do 20 times 19 times 18 times 17. And we get 116,280 different ways in which he can send 4 people to this musical. Pause the video and try this one on your own. You've got 7 articles related to the topic of your research paper. Your teacher only wants you to use 5 sources. In how many ways can you choose your 5 articles to read? Go ahead and try this now. Hopefully, you knew that you only want 5 articles. We don't care about which order. We're not ranking them in order of our favorite. We're just choosing 5 from the 7, which is why this is a combination. For the first article, you have 7 to choose from. But if you want 5 sources, you're not going to have still 7 to choose from. You've already chosen one. Now you have 6 left. Then for the third article, you only have 5 left to choose from. Then for the fourth article, you have 4 left to choose from. And for the fifth article, you have 3 left to choose from. Then we use what we know about the counting principle to do 7 times 6 times 5 times 4 times 3. And we end up getting 2,520 ways in which those papers can be chosen. I want you to pause the video and read this problem, and I want you to think about how this problem is different from the previous problems. While social distancing, you and your siblings decide to play some games. You have 15 games in the closet. You only have time this week to play 5 games. You're very busy with all your e-learning. You decide it's okay to play each game more than once. How many ways can you choose which games to play? Well, again, order is not important here. We're just choosing 5 games from 15, so there are 5 slots to choose from. So far, this is exactly like the other problems we've done. Here is where it's different. You decide it's okay to play each game more than once. So for the first day, you have 15 games to choose from. But it's okay with you if you play the same game again, so you still have 15 to choose from, and 15, and 15, and 15. So whether or not something repeats is important. Most of the time, you will not be repeating things, but some cases they will be, and that will tell you in the reading. So when I do 15 to the 5th power, or 15 times 15 times 15 times 15 times 15, that gives me 759,375 ways in which we can select our games to be played. Pause the video and try these two. You're playing a game where you have to draw 4 cards from a deck of cards. Remember, decks of cards have 52 cards in them. Suppose you decide to put each card back after you draw it. So you're going to draw 4 cards, and you're going to see which 4 you get. The first time you draw, you have 52 cards to choose from, but you're going to put that card back. So now you still have 52, and you put that card back, 52, put that card back, 52. And so this becomes 52 to the 4th power, which is 52 times 52 times 52 times 52, which becomes 7,311,616 possible ways to draw those 4 cards. Now, you're going to change the game. You're going to decide not to put the cards back. How's that going to change your answer? Well, you still have 4 cards to choose from. You still start out with 52, but now 1 card is missing from the deck, so there's only 51 left. Then 50, then 49. Can't use exponents for this one because all the bases aren't the same. I have to do 52 times 51 times 50 times 49. And this time I get 6,497,400. So a smaller amount of ways because I have a smaller number of cards to choose from each time. Try an honors question now. Suppose a theater company is trying to select what they're going to show this year. They have 11 musicals and 8 dramas to choose from, but they only have room for 5 shows. They decide to do 3 musicals and 2 dramas. How many ways can they select their shows for the year if they don't repeat any of the shows? Well, they have room for 5 shows. But this time, we have room for only 3 musicals and 2 dramas. They don't want to repeat any of the shows, so let's start with the musicals. They have 11 to choose from for the first musical, but now since they're not going to repeat, they only have 10 and then 9. And then for the drama, there are 8 dramas to choose from. So for the first slot, there are 8 to choose from, but now we've chosen one, so there's only 7 left. So now we're going to do 11 times 10 times 9 times 8 times 7, and that gets us 55,440 ways they can select their shows. Pause the video and try this one on your own. There are 6 women and 5 men interviewing for 4 cashier positions at Walmart. If we just fill the 4 positions, there are 4 slots available. There are 11 people, so it's 11 times 10 times 9 times 8. And so we would do 11 times 10 times 9 times 8, and that gives me 7,920. Now, what if we hire only women? There are still 4 positions to be filled, but we're only hiring women. So we only have 6 to choose from, then 5, then 4, then 3. We do 6 times 5 times 4 times 3, and we get 360 ways. And then for C, how many ways can the positions be filled if 2 women and 2 men are hired? Well, this is similar to the one we did about the musicals and the dramas. We have women for these 2 positions and men for these 2 positions. For the women, we have 6 to choose from, then 5. For the men, we have 5 to choose from, then 4. So we do 6 times 5 times 5 times 4, and we get 600 ways in which those can be chosen. You are done with today's lesson. Good job. Go back to haiku, click on the Google form for the IP combinations. Notice there's an honors section at the bottom. If you're not in honors, then you just skip that section. It will not count against your final grade. Good job today. Missed you so much. Hope to see some of you in my office hours. Have a great day.